In this example, I've designed a new centre line remote from the surveyed road because I want it to be clear of any planing or scarification works that go on within the road surface. So I'm going to use this centre line as a baseline for the design, although it doesn't affect the levels that I'm going to design for my overlay scheme. So the overlay design urban menu is available if you have a MX Urban license or a MX Road Suite license, and you can use this functionality to design best fit profiles and change the levels, crossfalls of the design to see how that design fits to the existing surface and optimize your design accordingly. So we'll just type in a scheme name, click next to get to the function control panel. So go into the define surfaces wizard and select our reference model, the baseline that I discussed a moment ago. Now again, I might have designed edges of road. In this particular case, I'm going to use the existing road edges. Select a style set to use for my new design. And just go and pick the survey as my survey and select the existing left and right road edges. I'm just going to reduce the left and right offsets. So that specifies the surfaces we want to use. So we click next to process that information. Okay, we get a graphic showing us where all the chainages are. We can insert chainages if we want to here, if there's special points of interest. I'm just going to click OK. Process all of that information. Now we see a graphic where the existing road surface is in white and the existing ground outside of that in green, and our designed surface is shown in yellow here. Now we have two strings in the designed surface so far because we said we wanted to use the existing road edges, so they're there in the designed surface. Click finish to come back to the function control panel. The street furniture option lets me specify pieces of street furniture just by picking them from the plan view. We see them in the cross-section view here, and these let me check that the design, for example, is above each item of street furniture. If I can achieve that, it'll be cheaper to construct the scheme than to take the cover off the street furniture item, lower the chamber inside it and rebuild the cover. So I might want to try and make sure that my design is above the street furniture. There may well be occasions when I can't, but it's something that I might want to check. The services option lets me pick a string, and I'm just going to select my services model, and I've got a waterline that's been picked up through the road here. I'm just going to say that it's a 225 diameter, and I'm interested in a minimum depth of cover of 500 millimeters. So I want to know if I'm getting closer than 500 millimeters to that, to the top of that string. So we just click next, and we see a profile and cross-section view showing the utility in the two views. Then the thresholds option is where I specify my design constraints relative to the existing surface. So in this example, I'm going to pick my existing left edge of road. Picked it from the wrong model. RD05 in the survey model. I want to project to RD05 in the design model, and I want to use a minimum vertical offset of plus 25 mil and a maximum vertical offset of plus 50 mil. In other words, I want my design levels for the left edge of road to be between 25 mil and 50 mil above the existing road levels. Now I can also use crossfalls here. So for example, I could have used this building frontage string here and specified minimum and maximum crossfalls and vertical offsets. So I could have said my minimum crossfall might be 1% and my minimum curb height might be 50 millimeters down, and a maximum crossfall of 4 or 5% and a maximum curb height. And these all create envelopes through which we might wish to fit the design surface. I'm going to keep it simple just by doing this one threshold. So we can just click onto the table and just check that we specified the right values. Click next to process. And then we see a cross section and a long section. I click in the cross section to activate the long section. So the yellow line in the profile view here is the current left road edge levels, and the two red lines are the top and bottom of the envelope or the threshold that we want to fit those road edge levels through. So click finish again. We've got all our information set up and we're ready to run parametric fitting. Okay, the check there, and we're into parametric fitting. Now we've again got annotation options, so I'm going to annotate, I'm going to do contours and I'm going to do level difference. Now the level difference by default is being annotated at every chainage on the scheme, so again I'm going to go into my scheme options and say I only want a regular chainage interval, and let's just increase that text height slightly to make those slightly easier to read. Now notice that these annotation options are actually color coded, so you can state what colors you need. So we're looking at level difference here. Okay, so the level difference is negative, it will be annotated in red. If it's 0, it's going to be annotated in black, but we've got a black background, so that becomes white. If you've got a positive level difference, it's going to be annotated in green. So we can see just by the colour of the annotation how our design is fitting. Now we've only got two edges in our design at the moment, so the first thing we might want to do is add the surveyed centre line. So I'm just going to pick it from the graphics here. Click OK. Now notice how the annotation updates. The contours have updated, so we've added our centre line into the design, and of course it's got a level difference between the design and the existing of 0. And we can see in the cross-section view, I'll just maximise that view. We can see the strings here, and we can tooltip them. We can tooltip the link to get information about them. We've got our utility line down here, our water main, and we can see at the moment it's over 1.5 meters below the design, so we've got no problems with clearance to that. So let's start amending the levels on the design. So I'll select the string that I want to amend. This is a very steep site in actual fact, so I'll just reduce the vertical exaggeration in the profile view. So let's say that we want to amend levels on the selected string, the centre line in this case, and I want to use a constant vertical offset of 40 millimeters. Now notice as soon as I type that number that the annotation updates. We can see our level difference values in the plan have updated. It's also updated in the profile view, so the green line's existing grounds and the yellow lines are design, so we can see the effect of that change before we've clicked apply. So we can assess the change before we say that yes, we're happy with it. So I'm going to click apply, which of course is going to give me a step of 40 millimeters at the start of the scheme, which I need to design out. So I'm now going to set a chainage range, and we'll say we'll take that step out over the first 30 meters. We'll use a reverse curve the levels are going to be relative to existing. I don't want to go relative to design in this case because they've already been lifted. So we'll say reverse curve from 0 to 40 mil over the first 30 meters. And you can see again how, as I've typed the values, the annotations updated. If I'm happy with that, I can click apply. So let's look now at this threshold that we specified on the left channel. I'll just maximize the view, the cross-section view here. So select that threshold, or the design string. We can see in the graphic the red here indicating that I need to be between these two red circles, so I need to raise this design left channel to get between my threshold limits. So I use the optimize string option for that. We'll create a best fit mathematical solution. Just zoom out slightly on this cross section. Okay, we can see all the IPs. Let's just zoom in here. Okay, so we can see the existing ground there. We can see the two red lines, which are our upper and lower bands of the threshold, and the yellow and the cyan for the grades and the arcs there. Now, as I say, it's a mathematical solution. We try our best to get through the envelope, but if I'm not quite happy with the design, what I can do is I can actually pick these IPs up and move them around. And notice that as I do so, the cross section's updating. What I can also do is I can come and hover over the left edge there with my cursor and right mouse click, and that locks the tooltip in place. So we can see, for example, I've got a level difference of 36 millimeters at the moment. If I come back up to the profile view and start dragging that point around, we can see how the level difference updates. So we can further optimize the levels along our design string to get the optimum solution. Once I'm happy with those, I can OK, and the design surface is updated. Now, if I want to make further amendments to that designed profile, I've got two choices now. I can either use the optimize option again, which will create a new profile through the threshold, or if I'm reasonably happy with the profile, I just want to make a few edits to it, I can use the regrade option to adjust that existing profile. I can now continue on with the design. I can use perhaps the add string using an offset option to build up a curb face or a lay-by or anything like that, and then I can use amend, crossfalls and things, options like that to further develop the design surface. One other option I'll demonstrate is the associate option. Now in this particular case we've only got these three strings in our design surface, so I'm going to pick the outer limits, okay, my two design edges, and associate them. Now if I now pick any of these strings, for example we'll just pick the right channel string there and say amend levels, any amendment to that string is going to affect all of the associated strings. So if I want to see what effect raising the right channel by 25 mil would have on the whole design surface, because the whole design surface is associated, we can see that that change affects the whole design. And this is really handy if, for example, you've developed a curb face and a footway, and your back of footway is tied into an existing threshold, but you want to change the channel levels, you want the curb to update, you just associate the curb strings, change the channel levels, the curb will go up and down as the channel levels change. The footway is still tied to the existing threshold because it's outside the association. So it's very powerful functionality to modify a selection of strings in one go. Again, I've got full undo and redo functionality, so I can step through my design changes. So the process would now continue changing levels, crossfalls, offsets, etc. to optimize my design. I'll click finish to process that. and then we're back to the function control panel, again with a common set of functionality on the bottom half of the panel, which we're going to cover later.